now, hydraulics are commonly used in mobile machinery, and there's increasing instances of electric actuators, right, replacing these systems. So maybe to start, Kirk, talk about what is driving the shift away from hydraulic technologies to electric actuators in mobile machinery applications?
Certainly, it's kind of connected with the electrification movements going on within the off-road world, or the trend in zero emissions, I guess is what they're trying to drive toward. Um, they always look at that as the first step. They replace the internal combustion engine with a battery system. And then a second step, a lot of times they want to make it more efficient, or they want to have oil-free features, and the electric actuation system can do both of those. So those are kind of the two main, or the main driving forces, the kind of the trend towards zero emissions.
And so are there, where are you maybe seeing electric actuators replacing hydraulics and mobile equipment? Are there specific maybe systems or machines where you see this occurring most?
Two main industries that have already kind of, you see it in the marketplace. There's a couple companies that have fully electric machines out there. One of them's in the scissor lift market, and then there's another in the small construction equipment market. Um, those are kind of the only two so far, but there's several projects we're working on. I'm sure other people are working on. It's kind of anywhere from the AWP markets to the work truck space, and also the ag equipment, who's used electric actuators for many years, but now they're starting to look at a few hydraulic replacement applications. And of course, like I said, the small construction equipment. In general, seems like most projects are kind of under 50 kilowatts or 75 horsepower. It's kind of the size machine that they're looking at. But we've got projects in all those different industries around the globe.
Hmm. Okay. And is there a particular reason those smaller kilowatt or lower kilowatt applications are being looked at the moment? Is it just that's where the technology is currently, or?
I think it's a mixture of both. So yes, for us, our particular company, that's where we have the technology. So we do get requests for larger applications, but it kind of fits cost wise with what's out there, what the batteries can do, and where it makes sense to kind of the smaller machines are going into municipalities and things like that, where they want to kind of have zero emissions. There are bigger equipment that's zero emissions, but for us, I think the electric actuators are kind of fitting in, like I said, under 50 kilowatts. It's a
Mhm,
good guideline. That's
mhm.
where our projects are falling.
Okay. And do you maybe have any like examples or just kind of able to touch on best use cases for electric actuators in mobile machinery?
Well, the application to machine where it makes the most sense is where there's only one or two actuators. Some machines that have multiple cylinders, like an excavator or skid steer, some of those applications, or tractor loader, it gets economically more challenging. The more cylinders there are. So like I said, I think where we've seen the most sense so far is, like I said, the scissor lifts and some of the work truck applications where there's only one or two cylinders on the machine.
When choosing to move to an electric actuator based system, what are some of the key factors which need to be considered when doing so?
One of the main ones, I guess, is the voltage, what voltage you want to have on your machine and what voltage you want to have the actuators running at. That kind of drives, the motor and the controller and everything else. Another big one that's needed for electric actuators versus hydraulics, you don't necessarily need this or look at it quite as heavily, but duty cycle has a large impact on the selection and size of the actuator. The other thing it's needed, if there's two actuators in parallel, kind of need to know that and take that into account, because electric actuators you have to synchronize, so it takes some control technologies to do that. So those three main factors, and the last couple are kind of the space claim is a big factor. It's not a drop-in replacement. And then last, it's probably the most important, is kind of what is the average load, not the maximum load, so we can really optimize the electric actuator.
And so would a company like Avelix work together with an OEM to help with that transition from the hydraulic systems they normally use to the electric actuators?
Yes, in our case, like I said, we've got a pretty large team, engineers that we got engaged, usually typically with their customers' engineers. Because like I said, there's a lot of CAD models have to go back and forth and have to change the frame of the machine. So like I said, it's not a drop-in replacement. It's not an easy process. It does definitely take some development time.
Hmm. Okay. And so what are then maybe some of the challenges related to replacement of, you know, these hydraulic technologies with electric actuators and, how might those be overcome?
As I mentioned previously, the space claim is the biggest challenge. Hydraulic cylinder, the motor is on the engine or somewhere like that. We're attached to near the battery pack. In our case, the motor and the gearbox have to be at the point of motion. So there's a big space claim there. So definitely, most cases you have to redesign your frame. So that's the biggest challenges. And then the other one is cost. It's still a cost adder. There's no guideline on what percentage, um, but that are some of the biggest factors. Uh, Resistance that'll get there. I think as we go forward, like I said, if people get used to designing them in on new machines rather than trying to retrofit existing machines, it's not a big challenge. And then the cost, I think, will continue to get better and go down as more and more people get into it, just as the volumes get larger. Uh, I think those will be
Hmm.
two trends that happen.
Okay. And so what would be the benefits maybe besides the goals of trying to achieve, the zero emissions or um, efficiency, or are those really just the only benefits of moving to an electric actuator system, or?
Those are the main two that we see that customer consider it. Because like I said, if you have a battery machine, you want efficiency. We see a lot of environmental places along the coast or along oceans. They don't want to have oil in their machines
Mm.
at ports and facilities like that. So we see that as really being a driver. There's some other features that people like once they get into it. They're very controllable, a lot easier to control electric actuators typically than hydraulic systems today. It's also a very simple system. You don't have a filter, you don't have valves, you don't have hoses. So it's a lot simpler, smaller bomb customers like once they get into it. So I think you'll start seeing those things are still the main driving factors um, behind why people do it. Seems like every customer's got different reasons why, but I think the efficiency and the lack of hydraulic oil or oil free is still the two major driving factors.
All right. Well, you were kind of touching on this before, but how do you maybe see use of electric actuators in mobile machines progressing in the coming years, and what might aid or even potentially hinder continued use of the technology?
Cost and the development time is a lot of customers just want to do it quick and drop it in there. With a battery system, it's not easy, but it's not quite as big a challenge. The combustion engine takes a lot of space. So,
Mhm.
but for us, like I said, there's a lot of development time to get it in there. And like I said, the upfront cost on the actuators is quite a bit more. Customers find long-term it's worthwhile because you don't have any maintenance really required, things like that. So the long-term equation looks good. So those are two of the major hindrances. I think the aid, what'll help it, kind of the environmental policies um, that are going on around the world. People are just being more realized that they need to look at the environment and that type of thing in their designs. Um, and like I said, mentioned before, the increased volumes as the motors get cheaper and the actuators will get more cost effective. I think those will help drive it. Certain applications will go, like I said, once again, one or two actuators that make sense. Some markets big, large excavators, things like that. I don't know if they'll ever go fully electric. But I think, the smaller machines and there's one or two actuators, or if there's some machine where there's a actuator way out at the end of a boom or something where it's really cost inhibitive to have run hydraulic hoses out there. Sometimes electric's a little bit easier in that environment. So once
Mhm.
again, small actuators, small machines, one or two actuators is kind of where I think it'll really go.
Well, thank you so much for taking the time to speak with me today and provide some
Thank you, Sarah, for
insight.
having me.
Yeah, yeah.